Good day, everyone. Today we are talking about section 10.6, add or subtract rational expressions. I can add, subtract rational expressions with common denominators. I can add, subtract rational expressions with different denominators. So in order to add fractions, you must have a common denominator. If you have a common denominator, like in these set of problems, it's just a matter of adding or subtracting your numerators. So for example, 3 over 8x plus 4 over 8x, our denominator, since it's the same, does not change. So it's just a matter of going 3 plus 4 is 7. And then because we're working with fractions, the last thing we have to check, does 7 over 8 reduce? It doesn't, so that would be your final answer. When we have expressions, we just need to add like terms. Again, our denominator is the same, so our denominator will stay at 4x. Here we have x plus 8 plus 3. Our like terms are the 8 and 3. So we're going to simply add those together to get x plus 11 over 4x. As we talked about in section 5, numerator is a binomial, our numerator is a monomial. Those don't simplify with each other, so our final answer is x plus 11 over 4x. Now on the last one, we have a subtracting problem. As we've talked about previously, mainly when we were talking about subtracting polynomials, whenever we have a subtracting problem, we're going to make it adding the opposite. So we have to change all of the signs in the second expression, the one after the subtracting. Again, our denominator matches, so it's going to stay 3x squared. And now it's a matter of adding those like terms. So we got 2x and negative x add to be x. Again, you can put the 1 if you'd like. 4 plus 1, positive 5. And again, we have a binomial over a monomial. That doesn't simplify, so that would be your final solution. Now, to add and subtract with different denominators, what we need to do is we need to make a common denominator. I will show you what I call the loop method. Do you have to do the loop method? No. But it does tend to be successful when we start talking about with variables. So what we're going to do is we're going to find what's called the least common multiple of our denominators. So 10 and 2. What is the smallest number that 10 and 2 both go into? So you should always start with, does the smaller number go into the bigger number? So does 2 go into 10? And the answer is yes, so that means 10 is our common denominator. Now when we talk about the loop method, we're going to draw a little loop from our top fraction to our bottom fraction. And I look at the denominator. What do I multiply 10 by to get 10? Well, 1. So then I'm going to multiply my numerator by the same thing. The left side did not change. It stays the same. On the right side, however, what do I multiply 2 by to get 10? 5. And then I'm going to take my numerator and multiply by 5 as well. So what we're saying is 1/2 is equivalent to 5/10. Now we are going to add our numerators so that we have our common denominator. So we're going to say this is a fraction over 10. 7 plus 5 would be 12. And then as always, we have to check. And in this case, this fraction reduces to be 6 over 5. So that would be your final answer. Same thing is going to happen with this one. So I'm going to skip ahead and then we'll come back and do that one. 2/3 minus 3/4. Again, a subtracting problem. We're going to make it add the opposite. So we're going to make it 2/3 plus negative 3/4. So again, when we're doing this, we're looking, what do 3 and 4 both go into? Our trick we worked on the first one, does 3 go into 4? No. So then we go, what is their first common multiple? What is the first number that they share in common on their times table? And that's 12. So on this side, we're going to multiply by 4, because 3 times 4 is 12. So 2 times 4 is 8. Over here on this side, 4 times 3 will give us 12. Negative 3, remember we changed that sign, times the 3 gives us negative 9. So again, our denominator will be 12. Add our numerators, 8 plus negative 9 is negative 1 over 12. Doesn't reduce our final answer. Take a moment, pause the video, and try these remaining two problems. All right, so on the first one here, we got 6 over 16 plus 5 over 16 gives us 11 over 16, which does not reduce, so that would be your final solution. Again, the last one, it was adding a negative. Did our loops 5 and 8. The first common multiple they have is 40, so we're going to multiply the left side by 8 and the right side by 5. Now, I've heard some people in the past say, oh, just multiply the denominators together. That works when the denominators are just numbers. But when they're not, and they have variable expressions in there, you don't want to just multiply the denominators because it's A, harder to simplify, and B, it doesn't quite always work that way. So we want to get in the practice of finding those least common multiples so that when we do work with variables, it will be easier to work with. All right. So here, for example, we'll start working with variables. The concepts are still the same as when there's just numbers. We're going to add. So we're looking at 2 and 7. Their first common multiple is 14. But now when we look at the variable part, we have to look at what is the common power. The thing is, when we're doing this, powers can go up, but they can't go down. In this case, both of them have an x, so our common denominator is going to be 14x. So on the right side, to multiply 7x to get 14x, we multiply by 2, so 4 times 2 is 8. On the left side, we're multiplying by 7, times 11 is 77. Add our numerators and we get 85 over 14x. That doesn't reduce, so that would be your final solution. On this next one, again, it's a subtracting problem, so we're going to make it plus negative. We're going to find our common denominator. 3 and 12. Does 3 go into 12? Yes. Another case in which we're not going to just multiply the denominators together. We want to find that least common multiple. And so we know we're going to have a variable because we have a variable in our denominator. Now, when it comes to picking powers, it's always going to be the larger of the two powers. So in this case, x cubed. So on the left side, what do I multiply 3x cubed by to get 12x cubed? 4. So I'm going to go 8 times 4 is 32. On the right side, what do I multiply 12x by to get 12x cubed? X squared. And if I want to put the 1 there, I can put the 1 there. So negative 5 times 1x squared will be negative 5x squared. And when we go to add them, these are not like terms. So all we are going to do is write them in standard form. So our squared term, our linear term, our constant term. Now, when it comes to simplifying, we would just check, is there a GCF of negative 5x squared and 32 that would, and then would it factor with our denominator? In this case, there's not a GCF, so we don't have to worry about that. So let's go over it one more time here. So again, we're going to start with looking at what number do 3 and 4 both go into? 12. And then what is the larger power? We don't need to do multiples or whatever. When it comes to powers, it's just going to be the larger of the two. So 3x cubed, what do we multiply to get 12x to the 4th? That is 4x, because we're short of a power as well. So we're going to go 2 times 4x will give us 8x. On the right side here, what do we multiply 4x to the 4th by to get 12x to the 4th? And that is 3. And then our last step, 8x plus 15 over our common denominator of 12x to the 4th. Our last C for simplifying, does 8 and 15 have a GCF? It does not, so that means it does not factor further. Please pause the video and try each of these three on your own. So as you're checking these, you can see your denominator of the first one was 33y. The second one, again, we start dealing with the different powers. 2 and 5 go into 10. X and x squared go into x squared. Again, powers can go up. They cannot go down when you're adding and subtracting fractions. And the last one, 3 and 4 both go into 12. X cubed and x to the fourth both go into x to the fourth. When you're doing these with monomial denominators where they're both monomials, one of the terms should get a power and one of them should not if they have mismatched powers in the beginning of the problem. All right, now when we start dealing with binomials, just like when we talked about in section 5, whenever you have a binomial in your denominator, we're going to put parentheses because it is an expression. And whenever we are dealing with binomials in our denominator, it is simply going to be a product of the two denominators. So it's going to be 5x times x minus 4. And this happens anytime there's a binomial expression in the denominator. If there's two monomials, we do like we did on the previous slide where you have to find the number, find the power. But if there's a binomial involved, like in this case, a monomial and a binomial, it's just going to be a product of the denominators. So on the right side, what do I multiply x minus 4 by to get 5x times x minus 4? So 5x. So then we're going to do 3x times 5x, 15x squared. On the left side, what do you multiply 5x by to get 5x times x minus 4? X minus 4. Essentially, we're multiplying by the other denominator. Now, again, put this in parentheses because you are going to distribute. You're going to go 12 times x and 12 times negative 4. So you get negative 48. And now when we go to collect our terms in the numerator, you're going to write this in standard form. So you're going to write 15x squared first, then 12x minus 48 all over 5x times x minus 4. Now when we go to simplify, we're not going to do the whole and done all that stuff. We're just going to simply look at, does it have a GCF? In this case, 3 goes into all of them. But does 3 and 5 reduce? No. So we are not going to take the step of reducing or factoring out the GCF because at the end, it's not going to do anything except create more work for no reason. All right, we'll go through another one here. So again, you're going to start with what is your common denominator? And then it's going to be a product of the parts. So parentheses around your x minus 1. So your denominator is going to be 2x times x minus 1. On the right side, we're multiplying by 2x. Again, if you need to put parentheses around your x plus 3 because it's a binomial expression, when you're multiplying x plus 3 times 2x, you are distributing. So you're going to get 2x squared plus 6x. On the left side here, we are multiplying by x minus 1, so we're going to distribute that and get 5x minus 5. And so when we come down here to add our like terms, squared term goes first, so we get 2x squared. Add the 5 and the 6x together to get 11x minus 5. And then our common denominator of 2x times x minus 1. Again, on a subtracting problem, plus, and then you have to flip all of the signs. So we're going to make it negative x minus 3. Once you've done that, it's the same as we were doing with the previous two problems. Your common denominator is going to be x times x minus 1. So that means over here we're multiplying by x. So you're distributing x to negative x minus 3. And on the right side here, we're multiplying by x minus 1 again. So you get 5x minus 5. Add your like terms, so we get negative x squared plus 2x minus 5 over x times x minus 1. All right, our last two problems. When you have binomial denominators, really this is the same as if there's a monomial and a binomial. Put parentheses around your two binomials, and your common denominator is their product. So on the left side, going to multiply by x minus 1. On the right side, we're going to multiply by x plus 2. Make sure you are distributing when you're doing this. Now adding like terms, so 9x and 5x would be 14x. 18 minus 5 is 13 over your common denominator of x minus 1, x plus 2. And our last problem, again, subtracting, make it plus the opposite. Our common denominator is x minus 3 times x minus 2. Multiply the left side by x minus 2, multiply the right side by x minus 3. Add your like terms, so 4x and negative 3x add to be 1x. Negative 8 plus 9 is 1 over our common denominator, x minus 3, x minus 2. And again, the order in which you write your denominator doesn't really matter. Typically, you'll see whatever's on the left, I write first. Whatever's on the right, I write second. If you have any questions, please come ready to class ready to ask them. Otherwise, have a great day, everyone.